So for example number 3, we're going to need to know a concept of a circumscribed angle. So if I have a perfectly drawn circle like this, and this is point of tangency A, point of tangency C, and this is B, then this is what we would call a circumscribed angle. So before, when we had an angle that was on the inside and the vertex was on the circumference or the perimeter of the circle, we call that inscribed. But when you have an angle that's outside of the circle and the actual rays of that angle intersect at one point on the circle, we would call that a circumscribed angle. Now there's a theorem behind this, and basically the theorem is this, that the measure of angle B is equal to (180 degrees) minus, and I'm going to put a little point right here, and we'll call this the center of the circle P, minus the measure of angle APC. Now the reason for that is that this is a, well, I don't want to explain it, but basically what you're going to do in one of our example problems is that to find the measure of this angle here, you're going to find the central angle of the circle, and you're going to say 180 degrees minus the central angle of the circle. Okay? Now the reason for that is that this, if you notice, this is 1, 2, 3, 4 sides. This is one angle, okay? And then technically of this quadrilateral, there's 1, 2, 3 other sides. And aside from that, we're just going to leave it at that. But this is the formula that you use, okay? And that's the circumscribed angle theorem. Okay? And so let's use that, all right? So now in example number 3, I have a perfectly drawn circle. And this is the point C, and then I have a big angle like this, where this is a point of tangency A, this is the point of tangency B, and this is the point of tangency D. And we're told that the central angle of this, because C is the center of the circle, is 135 degrees. And then we're asked to find ADB. So to find the measure of ADB, the formula is 180 minus the measure of the central angle. In this case, it would be ACB. Okay? So that's not that hard. This is X, right? Because they wrote that this was X. Is equal to 180 minus the 135. And that's just 45. Okay? That's pretty easy. There's a part 2 to this scenario. And that one's a little more complicated, but it isn't really, and I'll show you why. So another scenario that you might encounter is something like this. You have a perfectly drawn circle. I have a point of tangency here and a point of tangency here. I have the center G here. I have 30 degrees here. This is point H. This right here is point E. I have this point over here, which is J, and this point here, which is F. And so they give me this angle, right? This is X. Now this one is a little harder to do. In order to find x, I need to find the measure of angle EJF. And so I gotta think out loud, how do I find the measure of EGF? Well, this, you gotta we're gonna have to build on all the stuff that we've done. So that's equal to 1/2 EF. So whatever this is, it's 1/2 of that. But I don't necessarily know what 1/2 of this is. But what I do know is that this is the measure of this angle here. In other words, 1/2 EF, right? 1/2 of the arc EF, the measure of EF here, is equal to the measure of the angle EGF. So if I go EGF, well, EGF is the diameter, okay? But I could just say it's 180 degrees, but if I apply the circumscribed angle theorem, I know that that's 1/2 times 180 degrees minus the measure of angle EHF. Okay? The measure of angle EHF. So let's back up because this is going to be kind of confusing. This is equal to 1/2 of the arc EF, right? We all know that this angle right here is an inscribed angle, and the relationship between this angle is 1/2 of the arc, the corresponding arc, right? 1/2 times the corresponding arc. So then the measure of EF, right? The measure of EF is the same as the measure of the central angle, which is from E to G to F. Now technically that's a diameter, but this is the definition of a minor arc. Alright? Because we can't assume, I mean, to me it looks like that I shouldn't say it's the diameter. Really, I don't know. In the textbook, I'm going based on what I drew, but in the textbook I just kind of sketched this out. F is a little bit closer to here, so it's I can't be sure that it's 180 degrees. So this arc is equal to the central angle. Okay? So EF is equal to this. Let me write that down. So, well, from here to here is equal to the measure of the central angle. Right? So this is the central angle, this is the minor arc. So the 1/2 remains, and then I'm substituting this in for this. In other words, EF, the measure of this, is equal to the measure of angle EGF. Okay? Then, what is the measure of EGF? Well, if I go back and look at this circumscribed angle theorem up here, the relationship between this angle and the measure of the central angle is it's 180 minus whatever the central angle is. Well, this is the central angle, right? So then the central angle, if you redo the math, is going to be 180 minus the angle here. Alright, so I'm just taking this formula up here and I'm adding this to both sides, and then I'm subtracting this from both sides, and that's how I get this. So the measure of angle EJF is equal to 1/2 times 180 minus EHF. Okay? So we want to find x, and we've got to this point here. We know the value of this, so I say EJF is equal to 1/2 times the quantity 180 minus 30. So that's 1/2 times 150, which is equal to 75. I'll recap it one more time because that's a lot of information to kind of process at once. Okay. They want to know what x is. That's the measure of angle EJF. EJF. Okay? Well, that's equal to, because this is an inscribed angle, that's equal to this arc here, or 1/2 of it. So the relationship between this value and this value is that this is equal to 1/2 of this arc, the corresponding arc. Well, we know the relationship between this arc and the central angle is that they're the same, right? This arc is equal to the central angle. So for EF, I substitute in the measure of angle EGF, which is the central angle. But then I know there's a relationship between the central angle and this, and that's defined in my circumscribed theorem, right? This angle here, this angle right here, is equal to 180 minus the central angle. If I do just a little bit of algebra, I get that this angle x is equal to, in other words, what I'm substituting in for this is 1/2 times the quantity 180 minus this. So I'm just rearranging this line up here and plugging that in and substituting it in for the angle, the corresponding angle of EGF, which is the central angle. In other words, the central angle is equal to 180 minus this circumscribed angle. So I plug that in here. So this is substituted for this, is substituted for this, and the 1/2 just remains on the outside. Well, I know the value of this angle, so I'm just going to plug it in. And then from there, I just do the math. Okay? That was a good problem.